Fundamentals of Magento Development, Unit 6. Fundamentals of Magento Development, Unit 6.
The topic of this module is service contracts. There are several important concepts that have been incorporated into Magento 2, such as plugins, dependency injection, and service contracts. In this module, we will provide an overview of service contracts, focusing on the benefits of using service contracts, how they are implemented in Magento 2, and how you can customize Magento 2 using a service-based approach. Service contracts fulfill a number of important functions, such as improving the upgrade process, formalizing the customization process, and decoupling modules. We will look at each of these concepts in turn within this section.
.php. This is the public API class from one. For example, navigate to customer model data address.php. This is the public API class from 100.0.2. That means you as a developer can freely rely on this for your custom modules without having any troubles with future product updates. Basically, service contracts are a set of public API classes and interfaces, or codebase, that are available for you to make your custom modules or customize native ones. A service layer is used for making customizations without having to delve deeper into the product core. They also help with module interoperability. This is possible because the public API classes and interfaces, which are ones with @API PHP annotation, are frozen for any modification once they've got the @API annotation mark, so you can rely on that code and won't have issues with further upgrades. Service contracts are also designed to make the customization process more formal and straightforward, helping to minimize situations where you have to hunt for classes and haphazardly make changes that might fulfill one function but break others. Now all classes and interfaces with @API annotation are frozen for any modifications, so you can rely on that codebase, the classes and interfaces, to make your customization and have your code work with further Magento 2 platform upgrades. When you as a developer do something, you no longer need to rely on the implementation, but instead use public methods and parameters declared in public API classes and interfaces. The use of interfaces and APIs clarifies interactions with modules in Magento.
The diagram depicts a theoretical structure of APIs within Magento 2. Operations can be divided between two groups, data and operational. These terms are not formal, but are used to give you a better idea of how the various Magento 2 APIs are segregated.
In Magento 2, you can now customize a module using the public API classes and interfaces that communicate with the model without interacting directly with the core, a much safer approach.
What are some of the benefits of using a services approach? It provides comprehensive internal documentation that allows you to make customizations without having to go into the core. Following this approach helps to minimize conflicts between modules. Magento upgrades are much safer to execute without anything breaking. Clear extension points make customizations easier.
There are also some drawbacks to using a services approach, of which you should be aware. Services will often either be too simple or too complex, too broad or too granular. It will be more difficult to perform low-level, refined customizations. The approach may work differently with different implementations, and it may be more difficult to debug an application using this approach. Also, you need to assess whether the changes you propose are compatible with the public API codebase.
Now that we are finished with the overview, we're going to look more closely at the types of Magento 2 APIs, starting with the Framework API. In this diagram, we have separated the operational API into more detailed components, specifically the business logic API and repositories. The data API and the framework API remain their own logical units. Repositories provide the equivalent of service-level collections, while the business logic API provides the actual business operations. The framework API provides interfaces, implementations, and classes for various parts. Here is an example of a business logic API for the Magento catalog. The code provides an example of implementing the business logic API using the Magento Customer API Account Management Interface. To see an example for a concrete implementation, search for the public function Magento Customer Model Account Management Authenticate in the app installation. An example of a repository interface and its implementation. One important part of the operational API is repositories. Typically, a repository is an interface that provides access to a set of objects using the getList method. It has no obligation to extend something from framework. However, repository getList methods typically receive an instance of the search criteria interface defined as part of the framework. The framework also supplies an implementation for that interface, namely Magento, Framework, API, Search Criteria. We will discuss search criteria in more detail later in the course. As the diagram shows, the Data API implementation may extend abstract extensible objects, but it is also possible for Data API implementations to extend other classes or nothing at all. Business logic API implementations usually extend nothing. Repositories usually extend nothing, but expect a search criteria interface implementation as the parameter to their getList method. Now that we have finished our general discussion of the Framework API, we are going to look at the API in more detail, focused on repositories and the Business Logic API. In this module, we will discuss in detail repositories, search criteria, and Business Logic API. Repositories provide access to data sources, acting as a type of intermediary. The advantage to using this design pattern and its service API is that your application can function independent of the number of data sources and how they are connected to the app. This allows for easier upgrades. And since repositories deal with data objects and not models, the structure is compatible with any object relational mapping system. So for example, if you were to expand the product line of a store, in theory you could add data sources without having to modify the application itself. Only the repository would have to know about the new sources. This diagram depicts a repository accessing the database through a resource model and a collection. This chart presents a high-level comparison between repositories and collections, highlighting some of the facts we have already discussed. As repositories are services, they will remain unchanged with new releases, making upgrades easier. That is not true of collections. Repositories deal with instances of data objects, not models. Repositories use search criteria for filtering and sorting data, while collections use a method interface that can be customized down to very low levels. Almost all repositories have a getList method, which accepts a search criteria instance as part of its signature. Collections provide low-level access to select objects, which allow for custom queries. Here is a code example of a repository, the Customer Repository Interface. As you can see, the Customer Repository Interface is composed of a number of public methods, highlighted text, which all deal with the persistence layer. The parameters are Magento Customer Model Data Customer Instances, not to be confused with regular customer models, Magento Customer Model Customer. In looking at the get function, you will notice the customer registry object. Magento 2 has a number of smaller registries. If you call get with the same arguments 2 times, it will return the same instance. This is an example of the identity map design pattern. Here you see that the registry uses the customer ID to check if the requested customer model already was loaded. If not, the injected customer factory is used to create a customer model instance, which then is loaded. The fully loaded model is then placed in the registry properties Customer Registry by ID and Customer Registry by email. On subsequent calls, the customer already will be known to the registry and will be returned directly. This flow diagram is an illustration of the code we just examined on the previous slide.
This code example displays part of the customer repository getList implementation. The getList method now has been simplified. Now, to apply filter statements and sort order criteria, there is a collection processor. Use Magento, Framework, API, Search Criteria, Collection Processor.
This additional diagram focuses on the save method within the repository and the corresponding classes involved. Search criteria is the parameter in a repository's getList method, which defines filters, sorting, and paging. Looking at the code above, you can see how the search criteria instance is created using Search Criteria Builder. First, all filters are added to the builder, and then the search criteria object is instantiated using the builder's create method. Search criteria implements the search criteria interface and extends the class AbstractSimpleObject. It uses the set of filters contained within search filter group, which in turn wraps filter instances. Search criteria builder, extending AbstractSimpleObject, is used to create the search criteria object. Here is a list of the public methods available within the search criteria interface. We're going to look at the search criteria components and values in more detail. Filter group, filters, sort order, sorts, page size, limits, current page, offsets. Here is a list of search criteria builder methods that access the data array inherited from AbstractSimpleObject Builder. As you can see, this is not very complex code. It just takes an array and sets it on the inherited data array. Please note that usually the manipulators for the search criteria are not used. According to best practices, all properties should be set on the search criteria builder, which in turn injects the complete data array during instantiation. Once the search criteria has been instantiated in this way, only getters should be used on it. The filter class extends AbstractSimpleObject and adds the methods getSetField, getSetValue, and getSetConditionType. Just as with search criteria, even though the class exposes setters, it will usually be constructed using the filter builder, which injects all values during instantiation. This is the filter builder code, which is used to create instances of the filter class shown on the previous slide. In the previous two slides, we saw a high-level illustration and then a code example of filters and filter builders. This diagram demonstrates the relationship between filter group and filter group builder. The builder extends the AbstractSimpleObject builder, while the filter group extends the AbstractSimpleObject. Filters the group should include are set on the filter group builder using the setFilter method, and then the filter group is instantiated as usual using the builder's create method. This diagram demonstrates the relationship between sort order and sort order builder. Sort order builder creates the sort order after the fields and directions are specified using the methods setField and setDirection. The builder also extends the AbstractSimpleObject builder, while sort order extends the AbstractSimpleObject. As its name implies, search results is an object that represents search results. It is the base interface returned from repository getList methods. This code example lists the public methods of the search results interface. In the Service Contracts Overview module, we discussed how the Framework API could be thought of as composed of two related APIs, the Data API and the Operational API. In the following module, we then looked at these components in more detail, dividing the operational functions into repositories and a Business Logic API. We are now going to look at the Business Logic API in more detail. This overview diagram illustrates how the elements that compose the theoretical API relate to a module. The Business Logic API contains all the logic not contained within repositories or the Data API, and is responsible basically for all the actions a module can take. In the Business Logic part of a module, you have unique features such as sending an email, selecting a product, and placing an order. Here are some examples of the Business Logic API contained in the Customer module: validate, authenticate, resend a confirmation, and more. Here is an example from the Account Management implementation: resending a confirmation email. As usual with an implementation, we have an interface that specifies the method signatures. In some cases, it will be specialized classes that implement the interface. Otherwise, it is a regular Magento model. See your course Exercises Guide for instructions on how to complete this exercise and its solution. We will now shift our focus to examining the Data API, the remaining aspect of the Framework API. In this module, we will discuss the Data API Overview, Extensible Objects. Note that APIs are used both within and outside of Magento. Every module has an API folder that is available to the outside by calling it through a web service like SOAP or REST. This aspect will be examined in the next final module. As we have discussed earlier, we want our models to have an API, and we want to be able to very clearly specify which data is passed in and out this way. How do we define the type of data? The solution is the Data API. Data objects are essentially a set of fields defined by an interface that allow us to describe the type of data to use. The Data API defines the getters and setters for each of these fields. Secondly, we need some flexibility to define new attributes, provide information about relationships, and so on. The Data API is designed to meet this need by allowing the assignment of custom attributes. This may seem somewhat of a contradiction. We want the API to offer flexibility, yet we also want it to provide a well-defined structure for interacting with services like SOAP. We will examine both aspects in this module. How do you implement the Data API? We already know that there is a Data API folder that contains interfaces which describe the data objects used by the Service API. There are two possible ways to implement the interfaces. One is to create dedicated data objects, objects that solely contain data and have no behavior beyond getters and setters. This is outlined in the Customer Module column of the table. The second approach is to operate with regular models that additionally implement the getter-setters defined in the Data API interface, besides containing their business logic. This is outlined in the Catalog Module column of the table. The recommended way to work with Magento 2 is to have dedicated data objects that implement the Data API interfaces. Over time, the core team wants to refactor all modules to use this approach. Basically, both approaches operate with the Data API interfaces. In the first, customer case, if you call the Customer Module API, it will return instances of classes that only implement the data interface. If you call the Catalog Module API, it will return instances of regular models that implement the Data API interface. So in general, you should rely only on the interface methods, as the implementation may vary or be changed in future releases. Look at the methods within the interface and restrict yourself to using only those. Do not rely on, for example, a model save method, since that may change in future releases and break your system. This is why Magento 2 introduced service layers and API interfaces to make upgrades safer. The customer repository is an example of the implementation of data objects. In the product repository example, you see that the service layer API directly returns the product models. Both approaches generally use search result interface.
Congratulations, you have completed Unit 5. Close this window to return to the Learning Management System and proceed.